Okay, so we have looked at the tension force and how to get that, and then we've talked about the cross-sectional area. This time we're going to talk about what we're going to do with those two numbers to find our tensile strength. Okay, so tensile strength is similar to the amount of stress a material can take. So the ultimate tensile strength is the maximum stress that a material can withstand while being stretched or pulled before breaking. The tensile strength is recorded in units of pascals, which is abbreviated PA. So if we look over here, we have some typical tensile strengths of materials, and it's recorded in millions of pascals. Okay, so concrete has 2 to 5 million pascals. Okay, so 2 to 5 million newtons per meter squared. Okay, per square meter. Bone has 130 million newtons per meter squared. Okay, that's what the pascals are. Okay, so these are just kind of some normal things. It would make sense that diamonds are very, very strong, right? Whereas human skin is not quite as strong. Okay. Calculating the tensile strength of a material is done by dividing the maximum tension force by the cross-sectional area of the sample, right? So we find the maximum tension force, right? We use our graph to do that. Then we calculate our cross-sectional area and we divide them, okay? So for example, if we're looking at a rubber band, and the rubber band measures 5 millimeters wide, okay, by 1 millimeter thick, and it breaks at the 75 Newton mark. What is the tensile strength of the rubber band? In this case, we know that the tension force is 75 newtons. So in our formula, we're going to do the force is equal to 75 newtons, okay? We're going to divide that by the cross-sectional area. So remember, the cross-sectional area, in this case, we're going to have a rectangle. So you're going to change your 5 millimeters to 0.005 meters and your 1 millimeter to 0.001 meters. Then you're going to multiply those together, okay? Then you're just going to do the math, right? You'll take 75 and divide it by whatever this number comes out to. And when you're done, you'll have 15 million pascals. So what we could write is 15 capital M PA, right? There's nothing wrong with writing it as 15 million PA. But at some point you'll have so many zeros that you lose track of what you're doing. And so it's really helpful to be able to put things into terms of millions of pascals. Okay? All right, so that is how we calculate the tensile strength of a material. Go Hawks!